Hello guys, you are welcome to Network Pips. So in one of our previous videos, we discussed about different types of network device that we have. We mentioned the router, the switch, the access point, and the list can go on and on, as maybe the firewall, the network controller, and the rest of them. So, but in today's class, we'll be looking at more into the network, the switch device, getting to understand how this device function very well, how it makes its forwarding decision, and how it enables communication to happen on our network. So, having said that, the switch device forwards frames on our network using what they call the MAC address. This MAC address is nothing but a 48 a 48-bit hexadecimal value that is separated by period or column or hyphen, whichever way, depending on the vendor. So this MAC address uniquely identify our devices. So no two devices can have the same MAC address in a network. So so having said that, let's find out how switch learns this MAC address and make forwarding decisions using these MAC addresses. So let me say I have a PC connected to this switch over here, and I have another PC connected to this other switch over here. Let me say this guy is A, and this one is, let me say, B. And of course, for communication to happen between these two devices, they will need what, an IP address to enable communication to happen between these two guys. So I'm going to give this PC A an IP address of let me say 192.168.1.1/24. And let me say this guy is 192.168.1.2/24, for instance. Then of course they will have a MAC address. Let me say the MAC address of this guy is, let me say, x.b for an instance, and this guy is, let me say, s.a for an instance. And that's it. So if this PCA wants to send a message, let me take for instance the message is something like maybe a ping message. For an instance, a ping message is for testing reachability to an end device. So he wants to send that message to this other PCB. This message is going to contain at least 4 things. One of the things it's going to contain is going to contain a source IP address. This source IP is the origin of the message. Where is this message coming out from? In this case, it's going to be 192.168.1.1. This message is going to contain also the source MAC address. It's going to contain the source MAC address. So it's going to be the unique 48-bit of that device which that message originated from. In this case, it's going to be s.a. This message is going to contain as well the destination IP. Of course, you can't go to someone's house, remember, without knowing that person's address. So in this case, A has to know B address. Just like if you cannot visit facebook.com without typing facebook.com. You know facebook.com, that's why you have to type facebook.com. So he knows this PCA knows this PCB IP address. So this message is going to contain the destination IP as well. After that, it's also going to contain what again? The destination MAC address. So in this case, this destination MAC address is unknown. But for now, because this is the first initial communication, he does not know this destination MAC address. So this PCA is going to look, oh, I don't know this destination MAC address. He's going to first of all send out what they call an ARP message. An ARP message. Okay, and this is an ARP. It's going to send up what they call an ARP message, address resolution protocol, to resolve the unknown MAC address on our network. That's what an ARP does. So it's going to send that message to this switch, Once that switch receive this message, an app message is a broadcast message. So once that switch receive this message, it's going to send it out from his whole port, apart from the receiving end port. So it's not going to send it out to this port, but if there is a PC connected here, for an instance, that PC is going to receive that message. It's going to send it out to this port as well, to this other PC, to this other switch, I mean to say. So if there is, this switch is going to receive it and send it out of his own port as well, because it's a broadcast message as well. So this switch is going to send it out to this port. If there is a PC sitting over here, this PC is going to receive it. There's another one sitting over here, is going to receive it. So this guy is going to receive it as well, the PCB. So it's only PCB that will receive it and see, oh, this message will be like, hey, who is 192.168.1.2 on this network? So PCB is going to receive it and be like, oh, I'm 192.168.1.2, and I think someone out there is looking for my MAC address. It's going to attach his MAC address to this message, to this app message, his MAC address to this app message, and send it back to this switch. So this switch is going to receive it and send it back to this guy, and this guy is going to receive it and now send it back to this PCA. Then the PCA will now receive this message and fill in this gap, then send this message back, and it will be delivered to this guy successfully. So rewind back to when this PC received that first app message. Remember, when he received that first app message, that message contained one MAC address previously, the source MAC address, and the source MAC address was the MAC address of PCA. So a switch has what they called a CAM table, a content addressable memory, or you can call it a MAC address table. What switch uses this CAM table to do is to store all the MAC address that he learned on that network with the source port that he learned that MAC address from, and the VLAN. Don't worry about it if you don't know what VLAN is for now. We're going to tell you guys later in this course. So it's going to store this guy. Let me say this guy is coming out from maybe F0/0. It's going to store, oh, I learned this guy X.A from this port, F0/0 from this port. And remember, this guy replied back with an additional MAC address, the destination MAC address that this guy was asking for. So when this switch received it as well, it's going to store it again. Oh, I learned another MAC address, which is X.B on this network. Maybe it's going to store it maybe as maybe F0/1, for example. So on that network. So that's how switches learn these MAC addresses. So subsequent time, if other device wants to make communicate to these devices that he have already stored their MAC addresses on his CAM table, he's going to, maybe, let me say this is PCC. He wants to communicate to, let me say, PCA, for an instance. He's going to receive that message. He'll be like, oh, I've already known this MAC. He's going to check his MAC address. I already know this MAC address. I learned this MAC address from F0/0. Going to forward that message to this guy immediately. He's not going to broadcast it again. You understand? So that's how switches work. So it makes decision based on the MAC address that he learned and stored them on his CAM table. And by default, all the MAC address stored on this CAM table is going to last for 5 minutes. 5 minutes. Though you can extend it, it's extendable. You can extend it as well. But if you don't want this MAC address to expire, you can configure them as static, so they will not expire in future as static. So having said that, let's see how this thing works in our using our packet tracer. If I jump right into our packet tracer, I go to my switch connectivity, my network devices, click on network device, click on the switch. I'm going to pick this first switch, the 960 switch. to achieve this. Then click on my end device. I'm going to pick my, let me say my PC over here, pick another PC over here to enable this communication. Then pick my connector. I just pick this one, it should be straight through. Then pick another one. Okay, let's plug it to F0/2, F0/2. Then yeah, that's all. So by default, when a switch boots up for the first time, it's going to learn all the MAC address that's connected to this PC within the next 5 seconds or 10 seconds. But let's see if that's the case here. So okay, for this thing I control Alt 6. So show MAC address table. You can see the MAC address is empty. He does not know anything now currently, because of what we have not assigned any IP address to this device. So I'm going to assign an IP address. Let me say I'm giving this network, let me give them 192.168.10.0/24 /24. I'm going to give this guy, let me say this piece, I'm going to give him .1. I'm going to give this guy .2 for example, and the assign IP addresses to them to enable communication to happen. So oh, that's not where they put IP address. So here, okay, so 192.168.10.1/24. the default is going to be 255.255.255, this thing. Then come here as well, do the same thing here, 192.168.10.2/24, then cancel. So I believe maybe by now this switch must have learned this MAC addresses. Okay, I told you. So by default, within the first 5 seconds or 10 seconds, the switch will learn all the MAC addresses on their network. But if you leave this communication for if they are idle on your network for the next 5 minutes, it's going to unlearn these MAC addresses automatically. So you can see it have learned the one of this guy is on F0/1. It learned this one from F0/1. It learned this one as well from F0/2, which is one for the second PC. So these MAC addresses are going to expire. So how are we going to you can extend, how are we going to let me take for instance, I don't want these addresses to expire in future. Let me so one of the reasons why we might not want this address to expire, you can see the time it took us to resolve one unknown MAC addresses in the sketch I just showed you guys. So maybe there are some devices on your network, maybe the server, maybe you want this server, you want this switch to know the MAC addresses of this server and not to unlearn them on your network. So to do that, let me go to this device and for example, go to the command prompt to find the MAC address of this device. I'll do IP config /all to find the MAC address of this device. So if I come to this to the fast Ethernet interface, you can see the MAC address is also known as the physical address. So I'll copy this address now. So thanks to packet tracer, you can copy out this. So but if it's in a real life world, you're going to jot it down on a piece of paper, of course, or copy it out and paste it on a notepad and come to the device and paste it. So I'm going to come here. Let me see. Okay, it's still learning it. So I'm going to come here now. Go to our enable mode, go to configuration mode. So to statically assign this address, so it will not learn it again. You can see this type of learning this MAC address is dynamic. So I want to statically assign it so it will not unlearn it on our network. So I'm going to use the command MAC address static. Then it's going to ask you for that static IP. I'm going to paste it here. Then it's going to ask me for the VLAN. By default, all your interfaces will be on one VLAN, which is the default VLAN, the VLAN 1. Don't worry about if you don't know what a VLAN is. Now I'm going to explain to you later. Then you specify the interface where this device is connected to. So it's connected to, let's find out. It's connected to F0/1 on this switch. So I'm going to type F0/1. Then that's all. So it have statically assigned this device to our network device. To verify my configuration, I'm going to use do. Since I'm already in global configuration mode, do show MAC address table. Now notice what happened. It's no longer static. It's no longer dynamic now. It's now showing as static. So you can see this is the way switch learns MAC addresses on our network, and if you wish to statically assign these addresses on our table so it will not unlearn them in future, you can use that command. You can use the MAC address static command to statically assign that switch on network. So I would like to thank you for watching and see you in the next video. Thank you.